Welcome to the next lesson on Java readers writer locks. What we're going to do in this part of the lesson is first start by talking about the intent of reader writer locks, and we'll also give you an idea of a human known use of readers writer locks. The Java synchronizers we've talked about before, things like Reentrant lock, synchronized methods, synchronized statements, and so on, treat all the waiting threads the same, which is sometimes fine, but sometimes a problem. In contrast, readers writer locks, which is the subject of this lesson, are synchronizers that are used to solve so-called readers writers problems. So what the heck does this mean? Well, it means we're going to allow concurrent read access by multiple threads, but exclusive writer access. In other words, only one thread at a time will be able to write. And while the thread's writing, of course, we don't want any writers or other readers to be able to interfere with the critical section. It's a good idea, perhaps, to use readers writer locks when there are many concurrent threads that access some shared resource. Multiple of these threads can have read-only access and therefore are able to proceed at the same time, reading the contents of the resource. But only one thread can have write access at a time. There are two types of readers writer locks that are supported in Java. The Reentrant read-write lock is the classic way of supporting readers writer locks in Java. As we'll see later on, a Reentrant read-write lock is pessimistic. What that means is it assumes contention may occur and therefore has the locking mechanism set to ensure that things work when contention occurs. The alternative approach is called a stamped lock, and this is the newer and the much more high-performing way of supporting readers writer locks in Java 8 and beyond. Some aspects of stamped lock are pessimistic, but there's also something called an optimistic mode, in particular an optimistic read mode. And this can assume that contention won't occur and thereby can optimize the behavior in various ways, which we'll talk about later. Let's talk about a human known use of readers writer locks. One example, which many people may be familiar with, is the use of a readers writer locking protocol for updating material on a website that changes infrequently. For example, the Vanderbilt undergraduate course catalog is accessed continuously, is read continuously. But it only changes typically once a year. Once a year, say in April or May, the catalog is updated. So there's one write, but gazillions of reads. Therefore, we want to have some way to allow multiple readers to access the catalog concurrently, because there's no sense slowing everybody down just because it will change once in a blue moon, once a year. However, we want to be able to provide exclusive access when the single reader comes along. Sorry, the single writer comes along. When the catalog is actually updated annually, then we want to make sure that nobody else can be reading that document while it's being updated, because that might end up being confusing and cause some corruption. So that's our introduction to readers writer locks. Of course, we will go into a lot more detail shortly as far as how the various Reentrant read-write lock and stamp lock mechanisms work in Java.